We didn't get an equation.
What?
We stopped like at 12. We didn't finish at 12.
No, we're still on 11. So we're on problem 11. And we got an equation for B. We did part B, we got an equation. And we used the equation to make a prediction. We compared the prediction to the actual data point. Kids, I'm 63 and I can remember that. You have got to be able to remember that we did that yesterday, right? Okay, so now we're at the point where we're ready for C, but I need to know what my equation was. Y equals what? I did not write it down. 0.4x.
Minus
793.3. Yeah. Is that okay? All right, so this is the equation that we came up with by doing what? What did we do? We took the first two data points in the set, because they told us, use the first two, and we wrote the equation, right? Point slope or something, we wrote the equation. All right, so now, we're gonna graph that equation on our calculator, but we're gonna superimpose that equation on the actual points, the data points, to see how close we are. Everybody okay? All right, so first things first, all right? Looking at the data points that are given, we have some x's that range from what? What do our x values range from? 1998 to 2003. And our y's range from 5.9 to 7.8. Okay, so if I want to graph these, I have to make sure that my calculator window is appropriate for that. My calculator standard window is -10 to 10 and -10 to 10. That's my standard window. Is that window going to work for these points? No. You can't. Can you plot the point 1998, 5.9 on that grid? No. So the first thing we're going to do is make sure that our window is appropriately sized. Okay. My recommendation to you is go a little bit below and above the actual numbers you need. So maybe for our x's, maybe we'll go from 1990 to 2010. Just giving myself a little bit of room. So go to window, windows there in the top row, that's how you determine how big your screen is. And where it says X min, let's type in 1990. And where it says X max, let's type in 2010. We don't need to change anything else. Those are the X's. Everybody okay with that? Now, what are we going to do with our Y's? Maybe we'll just go 0 to 10. Are there other things we could go to? Do we have to be 0 to 10? 0 to 10 is fine. If you want to use 1 to 9, I don't care. But something on either side of those numbers. So Y min, I'm going to use 0. Y max, I'm going to use 10. All right? So now my window is set up appropriately for the problem. All right? Now I'm going to put in my data points because I have to actually do the scatter plot. So go to stat. And when you, stat, that's right here. My index finger is on it. You find the button that says stat. Okay? Now, go ahead and press enter because we're going to edit. We're going to put in data points. Do you already have data points in there? No, you're lucky. I do because obviously I've done my calculator before. So I'm going to tell you how to clear them. You can go through individually and clear each data point. And with a few, that's not bad. But when you have a whole bunch of data points that you want to get rid of, old data to get rid of, if you go back to stat, do you see one of your options is clear list? You see that option? Press stat. See it? So if you go down to clear list and then type L1 I looked when I had it open, when I had my screen up, I noticed it was L1 and L2 that I had stuff in. Those are the ones we normally use. So I will type L1, which is above the 1 button. You see above the 1 button how it says L1? So I'll type second L1, comma, your comma is above the 7. Did you press comma? L2, which is above the 2 button, and enter. Now, the calculator says done. So now when I go to stat and edit, you didn't see it before, but now my columns are empty. If you're confused by that, you can just go through and delete each one individually. But clear list, L1, comma, L2, will take care of it for you. Just get rid of all of it. Okay, so now I'm sitting here with a completely empty, like, T-chart thing. I'm going to put my points in. So I'm going to put in my X's, which are L1. They're in the first column, L1. So I'm going to type in 1998, 1999, right? 2000, 2001, 2002, and 2003. Okay, so you have your L1. Guess what you do now? You go over, and now you fill in L2. Now make sure that your L2s are lined up with your L1. So you want the right X with the right Y. So 5.9, 6.3, 6.7, 7.0, 7.4, and 7.8. Got them all in? All right, now I just want to check on something before we do the next step. I want everybody just press second quit. So second quit, and that just takes you back to the home screen. I want you to press Y equals and make sure you don't already have an equation in there. I don't want to have anything in there. Do you have? I do. I have something in there. Do you have something in there, or is yours blank? Y equals. Press Y equals right here. This button right here. Very first button on the calculator. Press Y equals. Do you have something in there already? If you do, you want to press clear. Get rid of it. We don't want to have that equation in there. Okay? Now, above the Y equals button, it says stat plot. So do you remember that a minute ago, we put our data in, and we put it in the stat menu? Remember we press stat? So now we want to plot that data. So press second Y equals. So now we're in the stat plot, like menu. And you want to turn on plot 1. So when you hit stat plot, it came up, plot 1's at the top, right? Number 1, plot 1. We want that to be highlighted on. So press enter and then highlight the on. So now you should have plot 1 should be turned on. So now you can plot points. So now we'll press graph. And did you get some points? Should have gotten 5 or 6 of them. Right? You get your points? So you just plotted the data points you put in. Okay, hang on. Now I want to go back to Y equals. And I want to type in this equation. Because our job was to put that equation on top of those points, right? So type in that equation, 0.4x. Does everybody know the x comes from the variable button? Right here where my finger is. And then minus 793.3. Now hit graph. Your points are still there, right? And what does your line look like? Doesn't it go through those points? That's a pretty good line, right? It's a pretty good approximation of those data points. All right, we'll try another one. Just hang on, hang on. Try to figure that out, talk to somebody, but that's how we do that. Okay? All right, let's look at problem 12. Remember, this is all videoed, so if I was talking too fast and you were not keeping up with your button pressing, you can go back and watch the video, stop it, start it, rewind it, whatever you want to do. All right, here we go, number 12. Mrs. Hastings Smith plans to invest some money. What are the possible values of X? So in other words, boys and girls, we're looking for the domain. What is the domain of this problem? Now think about that for a second. X is the amount of money that she puts into 5% account. So how much can she put into the 5% account?
18,000.
She can put a maximum of 18,000. So if I write this as an interval, the maximum amount is 18,000. What's the minimum amount? 0. There is your domain. What are the possible values of X? Anything between 0 and 18,000, right? Including those two. That's called your domain. Now, I don't think we're going to graph this one, but if we were going to graph it, what are these two numbers in terms of setting up my calculator? X min, X max, right? Those are the boundaries for X. We don't want to graph anything beyond that because it wouldn't make any sense. Okay. All right, if you invest X dollars at 5%, write an equation that describes the total interest earned in 1 year. So now we want an equation to describe how much interest she's going to earn in a year. So this is like Y. I'm using I for interest, but you can use whatever you want. All right, what do you think? She has invested X dollars at 5%.
1.05x. Or no, 0.05x.
Yeah, exactly, because we don't want the amount in the account, we want the interest. So the interest would be 0.05x. Does that make sense to you? Now wait, is that the total interest though? No, because doesn't she have two accounts? So this is the interest from the one account. What's the interest from the other account going to be? Somebody said 0.08y. Now, this kind of blows my mind because if I put 0.08y, how many variables will my equation have? There's one right there, right? There's one right there. I would prefer not to use y. Can we somehow express that y, that amount in the other account, in terms of x?
1800 minus x.
18,000 minus x, that's exactly right. Now, I want you to think about that for a second. What Lewis is saying is that I have this pot of money and I am going to break it up into two pieces. If I put 2,000 in this account, how much would be in that account?
16.
Now, how did you get 16,000? You took 18,000 minus 2,000. So if I put X in this account, that one is going to be 18,000 minus X, right? There's your equation. That's the equation. I know you can do some discriminant stuff, you don't need to. That would be the equation that describes the total amount of interest she's going to earn in 1 year. All right? How much did she invest in each account if the total interest is $1,050? All right, here's our equation. What are we going to do? Plug in 1,050 for I, right? All right, you can use your calculator to help you with this. I will be using my calculator to help me with this. Oh, I gotta pay attention to lunch times too. Never. If I tell you, you'll just be watching it. Okay, I hope all that chatter out there is math chatter. I got 13,000 for the 5% account. Anybody else get that?
How do you know which account is which?
You defined your variable from the beginning. It says you deposited X dollars in 5%. So when you set up the problem, the variable was actually defined for you, but you would need to define it. I am going to let X stand for the amount in this account, okay? So the way we defined our variable, that's the 5% account. And then that would mean there were $5,000 in the other account? Quit yawning, oh my gosh. All right, P4 done, P4 due on, what's today, Friday, Tuesday. So P4 due on Tuesday. We will probably be having a quiz after P5, but I'll let you know for sure. Depends how our timing is going. All right, P5, got some vocab here at the top. The zero product property. Anybody know what the zero product property is? You use it all the time. You just may have never formally discussed it.
Something from 0 to 0?
Okay, no, that's actually called the zero property of multiplication. The zero product property says that if A times B is 0, what has to be true? If you multiply two things and get 0, one of them has to be 0. So then either A is 0, B is 0, or both are 0. That's the zero product property. So that's what you do when you have a little equation like this and you factor it. What do we do after we factor it? We set them both equal to 0, because the only way this can be 0 is if one of these is 0, right? You use it all the time. That's what the zero product property says. A quadratic equation. Anybody know what that looks like? This is an example. A quadratic equation is anything of the form this, but A can't be 0. Because if A is 0, we don't have a quadratic equation, we have a linear equation, right? A quadratic equation is ax squared plus bx plus c equals 0. Now, these can be 0. You do not have to have a linear term or a constant term, but you gotta have a quadratic term, or it's not quadratic. Okay? Quadratic formula.
I want to try negative 2a plus or minus the square root of b squared minus 4ac.
Over 2a.
Okay, if you don't already know that, get it learned, people. Come on. All right? This is like in English class. This is like knowing what a noun is. You got to know some basic things, and this is a basic thing. Okay? Now, remember in the beginning we said that it's not quadratic if a is 0. So I don't have to worry about this variable down here because I know that will never be 0. So I'm good on that equation. That's called the quadratic formula. This, anybody know what this is called? The b squared minus 4ac. That's called the discriminant. B squared minus 4ac is called the discriminant. And why is it, like, why do we even talk about it? What's significant about the discriminant?
It can tell you how many answers you have to your equation.
Well, okay, let's back up. Quadratic equations are always gonna have two answers, okay? You're gonna have two answers. There's, the fundamental theorem of algebra says that every equation has at least one solution. A corollary to that says, whatever the degree of the equation is, that's how many answers there are. So in an x cubed equation, there are 3 answers. Now that blows your mind, because if I gave you this, you would all say, well, Miss Ford, that only has one answer. There only answers 2. No, there are 3 answers to this equation. The other 2 are imaginary. Okay, so you don't see them right off the bat, but there are 3. There are 3. There are 2 to every quadratic. So, Leah, it isn't, it's not so much that it tells me how many there are.
They're rational.
Yeah, it tells me what kind they are. That's exactly right. So the discriminant is going to tell me what kind of answers I have. Think about it. Remember, it's under the radical. So think about having a quadratic equation where the thing under the radical is, let's say, a 16. What happens to the radical sign? It goes away, meaning the answers will be rational, right? There's no radical left anymore. So if your discriminant is a perfect square, you're going to have 2 rational solutions. We're always going to have 2. In this case, they would be rational. What if the number under the radical, though, is a 17? Then the answer is going to be something like 2 plus or minus root 17 over 7, right? So we're going to have 2 again. So not a square. We're going to have 2 of them, but they're going to be irrational. So positive, but not a square. I'm going to add the word positive. It's a positive number, but not a square. Well, what if the number under there is a negative number, like negative 17? Then you're going to have 2 imaginary. So if it's a negative number, you're going to have 2 imaginary. I'm talking about the discriminant now, the discriminant. This is not new to you. You've talked about this before, right?
Yeah.
So I covered positive numbers. It matters if they're squares or not squares. I covered negative numbers. What have I not considered? 0? What happens if it's 0?
1.
Now, you want to say 1, and I'm okay with that. It'll be rational. But you're saying to yourself, wait a minute, Mrs. Ford, you said there were 2 answers. There are 2 answers. They just happen to be the same number. Because if it's 0, don't you get something like negative 5 plus or minus 0 over 2, something like that? So negative 5 plus 0 is one answer, and negative 5 minus 0 is the other answer. It just so happens they're the same. So in that case, there's only one root. When you graph your parabola, it looks like that. It only touches the axis in one place. Right? If they're imaginary, when you graph your parabola, it doesn't touch the axis. There are 2 imaginary roots there. There's no real roots. It doesn't touch the axis. A normal parabola is going to touch it twice like that, and you're going to get your 2 answers there. Okay? Now, there's a whole bunch of space under quadratic formula, and you may have written some stuff in there. I don't know. I didn't tell you not to, so you may have. But we've got some work to do in that space. What we are going to do, and as soon as we finish this, we will go to lunch. What we're going to do, and I hope we don't get interrupted, we actually might. What we're going to do is derive the quadratic formula. Now, in your math life, people have thrown a lot of formulas at you. I will throw a lot of formulas at you. We will not derive every single one because I only get to see you 3 days out of 4 for 50 minutes or whatever it is, okay? But you understand that these weren't just made up, right? You understand that every formula you use, somebody figured out, right? So we're gonna figure out the quadratic formula today. So, how we're gonna do it, did you do this last year? Not that you remember anyway. So what we're gonna do is, we're going to use the process called completing the square. You have done that before, but probably when you did it with numbers, and we're gonna do it with letters, so it's gonna seem a little more complicated. Step 1, we're gonna move that C to the other side of the equation. When we complete the square, that's what we do. We move the constant term to the other side. Then we're going to divide everything by A. Because when we complete the square, the process of completing the square, you cannot have a coefficient on x squared. That has to be a 1. So if I were doing a regular equation, and they said, Lisa, complete the square, I would move the 5 and divide everything by 2. That gets me ready. I have to do those 2 things first. Now, I'm going to add something. Does anyone remember the process, how we figure out what to add to both sides? Louis?
You divide the first variable by 2.
Okay, it's this one, the B term. So I have to divide, so in my example, I would divide 4 by 2, and then square it. So in this case, with the numbers, I would be adding 4 to both sides. It's half of the B term, the linear term, squared. So I need to take half of B over A. What's half of B over A? B over 2A. And then I need to square it. So I am going to add to both sides B squared over 4A squared. Now, why do we complete the square? What is the point? This right here needs to be a perfect square. So in my little example up here, this would be x plus 2 squared. You remember that? The reason you do it is to make a square. So what square is this? Well, I think it's x plus what? B over 2A. If you square that, don't you get that? And then over here, I need to add these 2 together. So I'll need a common denominator. So I'll multiply this one by 4A. Will that work for me? So now I have B squared minus 4AC over 4A squared. Now you know where this is going, right? What do I do at this point? Take the square root. And what happens when you square root something squared? Just leaves you with the thing, right? And what happens when I square root this mess? Well, it's plus or minus, because it's always plus or minus when I square root. Square root of 9 is plus or minus 3. I can't do anything with B squared minus 4AC, but what about my denominator? What's the square root of 4A squared? 2A. Last step, what am I going to do? Subtract this over, and I'm kinda out of room, but do you see when I subtract it over? They will actually have the same denominator, so I can write it as 1 fraction, negative b plus or minus. Now, did I just make your day or what? Yes, I did. That is awesome. Okay, I need you back in your seats. It's 12:05. Go to the bathroom, do whatever you need to do. Be back ready to work at 12:05.
They like, I brought my backpack in the